All right, let's talk about one of the coolest, most elegant pieces of biological engineering in your entire body. We're diving into the meniscus today. And trust me, it's not just some simple piece of cartilage. It's actually a brilliant solution to a huge design problem that affects every single step you take. Let's get right into it.
So here it is. This is the big problem. Believe it or not, whether you're a pro athlete or just walking to the kitchen, your knee is constantly dealing with a major mechanical flaw. So what is it?
At its heart, the problem is just simple geometry. You've got your thigh bone, the femur, which has this rounded end, and it sits right on top of your shin bone, the tibia, which is, well, pretty flat. Seriously, just picture trying to balance a ball on a flat tabletop.
And this is where it gets sketchy. When you put your entire body weight onto that teeny tiny point of contact, the stress, the pressure, becomes incredibly high. I mean, concentrating all that force on such a small spot, that's a recipe for total failure in any system, and our bodies are no exception.
Now, you might be thinking, okay, easy fix, right? Just change the shape of the bone. But it's not that simple. See, that creates this classic engineering trade-off. It turns out the perfect shape for just standing still is the complete opposite of the perfect shape for moving around.
Just look at this. On the left, if you made the tibia into a perfect cup, yeah, it'd be great for standing there. Super stable, spreads the load out perfectly. But the moment you try to roll or slide your knee, like you see on the right, you get what's called edge loading. All that force slams onto the rim of the cup. That would be catastrophic.
And this really lays out the paradox, the biomechanical catch-22. A cupped, concave shape is awesome for stability, but a flat shape is way better for the rolling and sliding our knees have to do. Since a rigid bone can't be both shapes at the same time, what does nature do?
Well, this is where nature gets really smart. It invents something truly clever, a structure that can actually change its shape on the fly, giving the knee the best of both worlds. It invents the meniscus.
And here it is. But listen, this thing isn't just some passive, squishy pad. The key words you got to remember are mobile and dynamically adapts. It's an active participant, constantly reshaping itself to protect the joint, whether you're standing, walking, or jumping.
This picture really shows it all in action. You can see the meniscus sitting right there between the bones. It's absorbing shock, it's spreading out the stress by making the contact area bigger, and it's making sure the joint fits together perfectly, what the experts call dynamic congruency, through your entire range of motion. So how does it pull all this off? Well, the meniscus basically has two design superpowers. The first comes from its unique shape. It's not a simple disc, it's a crescent, a C shape, and that shape is everything. This is just brilliant. Okay, follow me here. Step 1, your femur pushes down with a vertical force. Step 2, the C-shaped meniscus naturally wants to squish outwards, right? But, and here's the magic, step 3, these super strong fibers running all the way around its edge pull tight and stop it from expanding. That resistance creates tension, and we call that hoop stress. It's an amazing way to turn damaging downward force into manageable tension.
And if that sounds a little abstract, here is the absolute perfect analogy. Think of a wooden barrel. If you were to push down hard on the lid, the wooden slats would want to bulge out. What stops them? Those metal hoops. They're under tension, holding the whole thing together. Your meniscus works in exactly the same way.
And this isn't just a convenient comparison. It's literally how the meniscus is built. This anatomical shot shows that the strong collagen fibers that make it up are aligned in a perfect circle, following that C shape. They are perfectly positioned to be those tension-bearing hoops, containing the load and protecting the cartilage underneath. Just incredible. Okay, that was superpower number 1. The second superpower comes from its shape and cross-section. If you were to slice it and look at it from the side, you'd see it's not flat. It's a wedge, thicker on the outside edge and thinner on the inside. And this wedge shape is a total masterstroke of design. It basically makes the flat tibia act more like a shallow socket, which adds a ton of stability. But, and this is the crucial part, because the meniscus is mobile and can deform, it provides that stability without locking the joint. Instead of blocking movement, it guides it.
And you can see that guidance right here. Your knee doesn't just hinge like a door. It's this really complex combination of rolling and gliding at the same time. That mobile, wedge-shaped meniscus acts like a moving ramp that makes this complex motion totally smooth and stable as you bend and straighten your leg.
So we've seen how brilliant this structure is, but, you know, to truly appreciate it, sometimes you have to see what happens when the whole system breaks down. And this is what failure looks like.
This is a meniscal root tear. This is the anatomical equivalent of taking a giant pair of bolt cutters and snapping one of those metal hoops on our barrel. The entire structure suddenly loses its ability to contain force. The system fails. See, a tear like this breaks that continuous ring of fibers, and when that happens, the meniscus can no longer convert that downward compression into hoop tension. So instead of containing the load, it just gets squished out of the joint, and all that dangerous bone-on-bone stress it was designed to prevent comes roaring back. So, the meniscus is so much more than a simple cushion. It's a dynamic, shape-shifting, force-converting marvel of biomechanics. It's a perfect solution to what seemed like an impossible problem. So, right off the bat, here's the big mystery we're going to solve. Think about it. Your knee is this incredibly powerful joint. But without a really smart system in place, the massive forces from just moving around would literally shred its own cartilage pads. So how on earth do they manage to get out of the way every single time? We're going to break this down into 5 parts. First up, we'll look at the stage and rigging, basically how the menisci are anchored down. Then we'll meet the puppeteers, the muscles that are actually in command. After that, we'll watch the main event, the forward and back dance, followed by the complex twist, and finally, we'll look at what happens when that choreography goes terribly wrong. All right, so first things first. To understand how something moves, you've got to understand what holds it in place. This is the absolute foundation for everything else we're about to cover.
So, how are these C-shaped pads actually held in place? Well, there are 3 main systems going on. First, their ends, which are called the horns, are anchored directly into your shin bone. Second, they're attached all around their outer edge to the joint capsule. But it's that third one, the special ligaments, where things get really interesting and start to explain why the 2 meniscus in your knee act so differently.
And this slide right here shows the huge difference between the 2. The medial meniscus, that's the one on the inside of your knee, it's pretty much locked down tight by a big ligament. That makes it super stable. But the lateral one on the outside, it's not attached like that. It's way more free-floating, tied to the thigh bone instead. And this creates this critical design feature. One is built for stability, the other for mobility. And trust me, that's not just a fun fact. It's at the very heart of how your knee moves and why it gets injured.
Okay, so if they're anchored down, how in the world do they move? The short answer is, they don't. Not on their own anyway. They have puppeteers.
This right here is a really fundamental concept to grasp. The meniscus is just cartilage. It has no muscle, no way to contract or move itself. It completely relies on outside forces to pull it into the right positions, to protect it from getting smashed between your 2 biggest bones.
And here are the muscles that do the pulling. On the left, you've got the popliteus muscle. Its job is to grab the lateral meniscus and yank it backward when you bend your knee. And on the right, a part of your hamstring, the semimembranosus, does the exact same thing for the medial meniscus. See? 2 different puppeteers for 2 different puppets.
So that's pulling them back. What about pulling them forward? Well, that's handled by this absolutely genius system that's linked to your kneecap. When you straighten your leg, your patella slides up. This pulls tight on a whole web of tissues, including this transverse ligament that connects the front of both meniscus. And this one action just elegantly pulls both of them forward, right out of harm's way. Okay, so we've met the anchors, we've met the puppeteers. Now let's watch the main performance, the simple, everyday act of bending and straightening your knee.
So the first move in the dance is flexion. That's just bending your knee. As your thigh bone rolls back over your shin bone, the menisci have to glide backwards so they don't get run over.
And like we just saw, this isn't just happening by chance. It's a direct muscular action. As you start to bend, those posterior muscles, the semimembranosus and the popliteus, they fire up and actively pull the meniscus back, keeping them safe from getting pinched.
And of course, the second act is the complete opposite, extension, or straightening your leg. As the joint moves back into a straight line, the meniscus have to glide forward to clear the way.
And here's a closer look at that beautiful chain reaction we were talking about. As you straighten your knee, the kneecap glides up. This pulls on that whole network of tissues, which then pulls the front of both menisci forward, clearing a path for the joint. It's a perfectly integrated system.
Bending and straightening is one thing, but your knee also does this crucial little twist, especially when you lock it out straight. This is where things get even more sophisticated.
So how do they handle all this twisting? The rule of thumb is actually surprisingly simple. The meniscus just follow the rounded ends of your thigh bone, the femoral condyles, as they pivot. Just imagine them as these little sliding cushions that are programmed to stay right under the main point of contact no matter what.
Now this slide shows the final brilliant touch in the knee's design. It's called the screw-home mechanism. To fully lock your knee straight, your thigh bone actually rotates slightly inward. And look at the left image. As it does this, it pushes the stable medial meniscus back a bit, while the supermobile lateral meniscus glides forward. Then, to unlock the knee, like on the right, the whole process just reverses. It's this tiny little twist that gives a straight knee its incredible stability.
We've seen the elegant, perfect choreography. Now we have to look at that tragic moment when a dancer misses their cue.
And here it is, the core principle behind pretty much every traumatic meniscal tear. The injury happens when the whole system fails. When the meniscus lags, it doesn't follow the femur's lead, and it gets caught in the wrong place at the wrong time. This quote just paints such a powerful, visceral picture. The femur is the hammer, the tibia is the anvil, and the meniscus is what gets trapped in between. That's the devastating mechanic that causes a tear, especially when you have a sudden, forceful twist.
So we've seen the anchors, the muscles, this incredibly complex dance that protects your meniscus with every single step you take. The question this all leaves us with is a pretty big one. Now that we have this deeper understanding of the choreography, what can we actually do, through our training, through our awareness, to help this dance continue flawlessly for a lifetime?